card number 10 is the midpoint formula on a number line. It says that if AB has endpoints at x1 and x2 on a number line, then the midpoint M of AB has the coordinates x1 plus x2 over 2. And there should be, and I can see where my lines got off. There should be a segment line here and a segment line here. And you can see it's randomly in the middle. But anyways, okay. So basically, in order to find the middle, I take the two endpoints, add them together, divide by 2. Find the average. We've done that before. So example 8a says the endpoints of segment CD are -3 and 5. Find the coordinate of the midpoint M of CD. So you can draw a picture if you want to. For the first one, I'm going to go ahead and draw a picture. So here is our number line. Okay. And we have endpoint C, which is here. Well, hold on. Let me put -3 here. Then -2, -1, 0, 1, 2, 3, 4. We'll put 5 there. And we'll make sure these go because those are lines. And then we're looking at a segment. So that's going to be a point, and that's going to be C. 2, 1, 0, 1, 2, 3, 4, 5. And here is going to be D. And I need to make sure that I write that is 5. And I always like to write 0. Okay, so that's what it looks like. So we need to find M, which is the midpoint. And so up here, I know that M is equal to x1 plus x2 over 2. So that's the formula that I'm going to use when I'm finding M. I wrote it at the top. So I'm going to label C as x1 and D as x2. So M would be equal to x1, which is -3, plus x2, which is 5, over 2. So -3 plus 5 is equal to 2 over 2, which is equal to 1. So right now, I'm thinking that M is at 1. So I can check that simply by counting to make sure that it's in the middle. So if I count over here, I've got 1, 2, 3, 4 from M. 1, 2, 3, 4. So I'm all good. So the coordinates of M is 1. Okay. And now I'd like you to take a second to do the bottom one on your own. So go ahead and pause, work on the bottom one, and then come back and look at me working out the bottom one. Okay, so on the one that's on the bottom, 8B, it says the endpoints of QR are -5 and -1. Find the coordinate of M. So this time, I'm not going to draw a picture. I'm just going to find the coordinates of M. So it says that M is equal to, we're going to call this one x1 and this one x2. So that's going to be -5 plus a -1 over 2. -5 plus a -1 would be -6 over 2, which is equal to -3. All right. And as a check, if you wanted to, of course, you can draw a number line. I'd have -5, 4, 3, 2, 1, -1. And so then this would be my Q. This would be my R. I'm sorry about my phone. And then we would go, M would be at -3, 5, 4, 3, M. And we can count. So that's 1, 2 there. And 1, 2 there. And I messed up because I put R at 0 when really R is at -1. So the 1, 2 does work right there. Last card for this lesson, how to partition a segment. So for a segment JK with endpoints at x1 and x2, the point P is the partition, and it partitions the segment with the ratio of B to A. And in order to find that point P, we're going to do A times X1 plus B times X2 over A plus B. So basically, you are finding a portion of the line. So you're figuring out if I go 1/4 the distance or 3/4 the distance, or the distance is a ratio of 2 to 1, how does that work? So we're going to look at two examples. Example 9, A. The endpoints of segment AB are 2 and 8. Find the coordinates of the point P that partitions the segment in the ratio 2 to 1. So before I get started, I'm going to write down my formula so that I can make sure I know what it is and that I'm using it correctly and that I remember what it's supposed to be. So it is P, which is the point, the partition, is equal to A times X1. I don't know why I wrote that X little. So A times X1 plus B X2 over A plus B, where my ratio is B to A. And so you got to make sure you remember that your ratio is B to A. So the endpoints of AB are 2 and 8. So that means that X1 would be equal to 2. X2 would be equal to 8. And we're looking for the point that partitions the segment in a ratio of 2 to 1. So if my ratio is 2 to 1, then 2 would be my B and 1 would be my A. And I'm going to fill it into the formula. P is equal to 1 times 2 plus 2 times 8 over 2 plus 1. So 1 times 2 is 2. 2 times 8 is 16. 2 plus 1 is 3. So that's going to be 18 over 3. So P is equal to 6. So my partition would be at 6. And again, I'm going to go ahead and draw this one out so that we can make sure we see it and understand what we have done. So let's say here's 2, 3, 4, 5, 6, 7, 8. Here's 8. Okay. So at 2, I have A. At 8, I have B. And I have now just found P, which is at 6. So 2, 3, 4, 5, 6. So here is P. It's at 6. And so my partition has to be at a ratio of 2 to 1, because that's what it says right here. So I should have a ratio of 2 to 1. So let's check. So if I count on the right side, I have 1, 2, 3, 4. So on the right side, I have 4. And then if I count, I'm sorry, that's the left side. On the left side, I have 4. On the right side, then I have 2. So I have a ratio on right to left of 4 to 2, and we can reduce 4 to 2. We can reduce 4 to 2 as 2 to 1. So then my P is accurate. So that would be correct. So of course, now I want you to pause and work on 9B on your own and then come back and do it with me. All right, so we're working on our last example for this lesson. So the endpoints of EF are -3 and 7. So X1 would be -3, X2 would be 7. We're looking at a partition of 4 to 1. So that means that B is equal to 4 and A is equal to 1. So I'm going to do 1, well, P equals 1 times -3 plus 4 times 7 over 1 plus 4. So that's -3 plus 28 over 5. So -3 is 25. -3 plus 28 is 25 over 5, which is equal to 5. So my partition would be at 5, and we hope that that's a ratio of 4 to 1. So I have -3, -2, -1, 0. 1, 2, 3, 4, 5, 6, 7. So I have a point here. This is E. And a point here. This is F. And it's saying that my partition is at 5. 0, 1, 2, 3, 4. So hopefully that's P. And we want a ratio of 4 to 1. Well, real easy off the back, I can see that to the right of P, then my value is 2. So then to the left of P, I have 1, 2, 3, 4, 5, 6, 7, 8. So to the left of P, I'm at 8. And 8 to 2 certainly reduces to 4 to 1. So I'm accurate. And that is the conclusion of lesson number 4 on distance and length.